So this is part 1 of your review for lesson 8.2 on logarithms. And so what I have you do is to evaluate these expressions without the use of your calculator. But last time, if you watched the definitions for logarithms in the inverses video that I posted, we know that logarithms are inverses to base 10 exponentials. It's helpful then to think about writing each of the numbers you see in the logarithm as their base 10 equivalents. Well, if I think about 100,000, that's 10 to some power. And if one of the shortcuts we have for multiples of 10 is to simply count the number of zeros we have for whole numbers, or to count the decimal places for the fractions of the decimals as you see here. So I'll start with this one, and I know that 100,000 is really 10 to the 5th power. So I may rewrite this in equivalent expression as the logarithm of 10 to the 5th. Now logarithm, without the 10 written underneath it, is still recognized as the common logarithm, or a base 10 logarithm. So its unwritten rule is to have a 10 here. So the logarithm base 10 and the base 10 exponential cancel out, leaving you just the exponent behind. Okay? One of the things I like to say in class is that the logarithm asks this question. It says, what power of 10 is this number? That might help you to remember what you're working with. So what power of 10 is 100,000? The 5th power. What power of 10 will be this decimal version? Well, if you recognize this is tenths, hundredths, thousandths, 10,000ths, right? Then we're dealing with 1 over 10,000, which is equivalent to 1 over 10 to the 4th power, which we know is 10 to the negative 4. Therefore, the solution to this would read negative 4. But as I mentioned, the shortcut to looking at the fraction version or the decimal version of being a multiple of 10 is to count the number of decimal places. 1, 2, 3, 4. And knowing that it's a decimal, we'll call it negative 4. Let's keep going. This expression is almost easier than the previous ones. It's known to be a common logarithm base 10, and we have 10 raised to the 5.3 power. What power of 10 is this number? 10 to the 5.3. The answer is 5.3. And on this one, 10 to the log 12, the order is different. These were all asking logarithmic questions. This one is 10 raised to the power of logarithm. But if you remember, inverse functions work to cancel each other out, right? So these are still inverses to each other. They're going to cancel and leave just what's left over, the input. The input of 12 becomes the output of 12. So the answer to that one is 12. Here's a sample of logarithms and their base 10 exponentials.